Hello class and welcome to section 9.3, Properties of Logarithms. Before we go ahead and look at the properties of logarithms, let's just refresh our memory from what we did last section. So what we looked at was the inverse of an exponential function, and we discovered that the inverse of an exponential is a log. So we have that y, is equal to log base b. This is the inverse of an exponential function, okay? And just so that we remember, we could rewrite this as it's really base b to the y is equal to x, okay? So it's the inverse of an exponential function. Since a logarithm is an inverse of an exponential function, a lot of our rules for exponents work with logarithms, okay? So, product of powers. So if I'm multiplying monomials, remember we would add their exponents. So if I have 3 to the second times 3 to the fourth, it's really going to be 3 to the 2 plus 4. So it's 3 to the sixth. Okay, so that's how it can simplify. So we'll come back and look at division after a few examples. So let's just look at when we're multiplying with logarithms for now. Okay, so for all positive numbers m and n and b, where b does not equal 1, okay, we have that the log base b of two numbers being multiplied together, m times n, will equal log base b of m plus log base b of n. Same thing here. We were multiplying, so now I can add those exponents. So this example says log base 3 of 2 times 4. I can actually rewrite this as log base 3 of 2 plus log base 3 of 4. Okay, so we're going to use this property to help solve some equations. Example 1, we want to use log base 4 of 2, which is approximately 0.5, and log base 4 of 3, which is approximately 0.79248, to approximate the value of log base 4 of 6. Okay, well, I know that I can break 6 apart, and 2 times 3 is equal to 6. So I'm going to rewrite this as log base 4 of 6, okay, will equal log base 4 of 2 times 3. Using my rule now, which is also listed up here, okay, I can rewrite it with addition. So it's really log base 4 of 2 plus log base 4 of 3. Now I can go ahead and use my fact that I have here. Log base 4 of 2 is approximately 0.5. So it's really 0.5 plus log base 4 of 3. Well, it's approximately 0.79248. So I go and type into my calculator 0.5 plus 0.79248, and we get 1.29248. There is my approximate value of log base 4 of 6. Okay, let's go ahead and look at example 2. This one might be a little bit more complicated. Okay, so it says use log base 2 of 3, which is approximately 1.5850, to approximate the value of log base 2 of 48. Okay, this one's different because I can't just say, well, 3 times 16. They didn't tell me log base 2 of 16, so we have to figure out what that is. Okay, so let's just first of all break down 48. Okay, 48 is really 3 times 16. Okay, and I'm going to break it down even further. 16 is really 2 times 8, and this is really 2 times 4, and this is 2 times 2. So I can really rewrite 48 as, how many 2's are there? 2 times 2 times 2 times 2, 4 of them, as 2 to the 4th times 3. Okay, so I'm going to rewrite log base 2 of 48 is equal to log base 2 of 2 to the 4th times 3. Okay, times 3. Now I'm going to go ahead and break this down into addition. So really I have log base 2 of 2 to the 4th plus log base 2 of 3. Okay, let's go ahead and deal with this log base 2 of 2 to the 4th. Okay, I'm going to do it as a little side note. Okay, remember when we dealt with a problem like this yesterday, if I didn't know what it was, I could simplify by saying, well, this is equal to x, correct? So my base was 2, so it was really 2 to the x is equal to 2 to the 4th. Okay, so x equals 4. Well, and if x equals 4, this can take the place of it. So log base 2 of 2 to the 4th is 4. Okay, this will work as long as your base of your log and your base here are exactly the same. Essentially, these things cancel each other out and you're left with 4. So this is equal to 4 plus, now we have log base 2 of 3. Well, they told me that above, so I'm going to plug that in. So 1.5850. So I would add them together and I would get 5.5850. Okay. All right. Moving on to another example, example 3. So these are a little bit different, okay? If you look at this, it's log base 4 of x and log base 4 of x minus 6 equals 2, okay? So log on one side of the equation, can you combine the separate logs into one log? Okay, that's the first thing we want to do. Then we want to put it into exponential form and solve for x. So that's what we're going to do in order to solve this. So I look at this and I see that the left-hand side of my equation is an addition. And I say to myself, well, how can I rewrite a log with addition? Well, I can rewrite it with multiplication. So it is really log base 4 of x times x minus 6, rewriting with addition, or sorry, with multiplication, is equal to 2. Okay. Now I'm just going to put in exponential form. Remember my rules from last notes. It was log base b of x. I could rewrite this as b to the y is equal to x. So now I'm going to put it into exponential form using that idea. Here is my base. This piece over here is my exponent. And it equals what's here. So I'm going to take 4 to the second. So it's really 4 to the second is equal to x times x minus 6. That was what was in spot of this x here. Okay, so it equals that. Now I have 16 is equal to x squared minus 6x. I notice that it's a quadratic, so I am going to get everything to the right-hand side. So I'm going to subtract 16 from both sides. So I have 0 is equal to x squared minus 6x minus 16. Now I have to factor. So what multiplies to negative 16 but adds to negative 6? Negative 8 times 2 will give me negative 16. Okay, and if I add them, I get negative 6. Now my last step, set each one equal to 0 and solve. So I have x minus 8 is equal to 0, so I have x equals 8. And then I have x plus 2 is equal to 0. I would subtract 2 from both sides, so x is equal to negative 2. So I would quickly check if I go to my original, would everything be okay? Remember, you cannot take the log of a negative. So if x is right here, okay, this is my x. I can plug in 8 here, that's fine. But can I plug in negative 2? I cannot. So my only answer is x is equal to 8. Okay. Let's go ahead and try another example like this. Example 4. I would actually, yes, recommend that you pause the video and try example 4 on your own. Very similar to example 3. So pause the video, try example 4 on your own. All right, I'm going to go ahead and do example 4 now. So hopefully you've had a chance to do this one on your own. So I'm going to rewrite. I see addition, so I'm going to rewrite it with multiplication. So it is log base 8 of x times x minus 12. And that is equal to 2. Now I'm going to write it as an exponent. So it is 8 to the second is equal to x times x minus 12. Now I would simplify. This is 64 and distribute that x. So I have x squared minus 12x. And I would subtract 64 from both sides. So I would have 0 is equal to x squared minus 12x minus 64. And now I need to factor. So 0 is equal to what multiplies to negative 64 but adds to negative 12. That one might be a little bit trickier, but negative 16 and positive 4. multiplies to negative 64 but adds to 12. Then I set each one equal to 0. So x is equal to 16. X is equal to negative 4. Once again, there is just an x, and if I plug in negative 4, you can't take the log of it. So this one does not work, but x equals 16 does. Okay. So that is our rule for multiplication. Okay, you can rewrite it with addition. Now we're going to go ahead and look at division. Okay, so quotient of powers. So let's just look at how we did it with exponents before. Remember, when you were dividing monomials, you rewrote it using subtraction. So it'd be 3 to the 4 minus 2 is equal to 3 to the second. Okay, remember, you can rewrite this piece. It's at the very top of your notes on the front page. Okay, so now the properties that I have for logarithms. Okay, the quotient property of logarithms is actually written on the top of the back side of your note sheet, so that's where that can be found. So just like with exponents, I have written division here. So we have division, we can rewrite it with subtraction. So now if I have log base 3 of 4 divided by 2, I can rewrite it as log base 3 of 4 minus log base 3 of 2. Okay, so that is my rule with division. Okay, I can rewrite it with subtraction. So let's go ahead and do a problem similar to the first few on the front side. Is we know what log base 3 of 5 is and log base 3 of 20 is. Okay, we want to approximate the value of log base 3 of 4. Okay, so I have log base 3 of 4. What is that going to be equal to? Well, we know we can use quotient rule, okay, or we can use division. So I would say, well, using 20 and 5, how would I get to 4? Well, it would really be log base 3 of 20 divided by 5. That will give me 4. So since it's division, I can rewrite this with subtraction. So it's log base 3 of 20 minus log base 3 of 5. And now using the information they gave us, they told me log base 3 of 20 is 2.7268 minus my log base 3 of 5 is 1.4650. And using your calculator, you would subtract and get 1.2618. So that is how you would simplify that one. The next rule we're going to go ahead and look at is a power of powers. So remember, if I have 3 to the 5th to the 2nd, I would multiply those two. Okay, so it would be 3 to the 5th times 2, which will give me 3 to the 10th. So once again, logarithms has a similar type of property. Okay, is that if you have a power to a power, you're going to use multiplication. Might be a little bit differently than you would have thought, but see how I have a power here, so it's a power to a power. So what's going to happen is you can bring that p down in front, okay, because then it's going to be p times log base b of m. So if I look at my example, I have a power of powers, so it's really to the 2nd, so I bring that 2 down in front, so it's 2 times log base 3 of 5. So I can rewrite it with that multiplication. Okay. So let's look at example 6. Okay. We are going to use log base 4 of 6 is approximately 1.2925 to approximate the value of log base 4 of 36. So I know log base 6, and I know I can use my power of power rule. So I would have to say, well, 36, how could I rewrite that as a power to a power of 6? Well, we all know that 36 is actually 6 squared. So I'm going to rewrite it as 6 squared. So it's log base 4 of 36 will equal log base 4 of 6 squared. Now I can use my power of power rules, and I can go ahead and bring that 2 down in front to make it multiplying. So it is really 2 times log base 4 of 6. And now I can substitute. Okay, log base 4 of 6 is 1.2925. So it's really 2 times 1.2925. And if I get my calculator out and multiply those two, I get 2.6 0.585. Now let's go ahead and look at example 7. This one is a little different. Okay, we did some equations earlier, but there was only logs on one side of the equation. These problems, there's logs on both sides of the equation. Okay, so what needs to happen is you need to combine all the logs on one side, okay, and then cancel logs on both sides, okay, and then solve the equation for x. So I think this is easiest if we just go ahead and start working through it. So first thing first for number 7 is I notice I have 3 times log of base 5 of x. Well, if it's multiplication, I know it was a power of power, so I can go ahead and put that 3 back as a power. Okay, so this will be 3, sorry, not 3. It'll be log base 5 of x to the third. So I can write it as log base 5 of x to the third is minus log base 5 of 4 is equal to log base 5 of 16. Okay, well, I need to combine the two logs on the one side. So let's go ahead on the left-hand side. It's subtraction, so I can rewrite it using division. So it's log base 5 of x to the third over 4 is equal to log base 5 of 16. Okay. Now you guys can notice, as we've done other problems like this, we have a log base 5 and a log base 5. So obviously what is on the inside of them has to be exactly the same. So I would have x to the third over 4 is equal to 16, and I need to solve this. So I would multiply by 4 on both sides. So I have x to the third is equal to 64. Then I would have, in order to solve this, I would take the cubed root on both sides. So x is equal to the cubed root of 64. Okay, so you need to probably do that on your calculator. So cubed root is 64. If you do that, you will get that x is equal to 4. Okay, there is example 7. Let's go ahead and look at example 8. Okay. Example 8 is very similar, so I would recommend that you maybe pause the video and just try 8 and 9 right now on your own. So pause it, try 8 and 9 right now on your own, and then come back and I will finish those on the video. Okay. All right, I am going to go ahead and do example 8 right now. So same idea as example 7. I'm going to put that exponent back. Okay, so I will have log base 2 of x to the fourth minus log base 2 of 5 is equal to log base 2 of 125. It is subtraction, so I would rewrite subtraction with division. So I would have log base 2 of x to the fourth over 5 is equal to log base 2 of 125. Notice log base 2, so the insides should obviously be equal because they are the same. I would multiply by 5 on both sides. So I have x to the fourth is equal to 125 times 5 is 625. And then in order to figure out what x is, I would take the fourth root on both sides. So x is equal to the fourth root of 625. So I would recommend doing that on your calculator if you don't know what it is. I'm just going to show you on the TI-84 how to do that on your calculator. If you don't know how to do it on yours, let me know so I can help you. But on here, to find the fourth root, okay, you are going to go to the math, okay, math. And if you see how it's x square, it looks like a square root, but there's a little x here, number 5, that's the one you're going to use. Okay, I'm not really sure what happened. So didn't work out. So I'm going to hit 4 for the fourth root. Then I'm going to go math, and then down to number 5. I must have went to number 6 on the last one. So there's number 5. So it's the fourth root, and then I would type in the number 625. And you get that the answer is 5. So x is equal to 5. So there is my solution for number 8. Like I said, if you don't know how to do a fourth root or any root on your calculator, let me know and I can show you how to use that. And our last example, Same type of idea. I'm going to go ahead and put the exponent back. So I would have log base 7 of x to the second is equal to, and I'm going to go ahead and rewrite the right-hand side as 1 right away. This time, notice it's addition, okay? So with addition, we rewrite with multiplication. So it's log base 7 of 27 times 3. So this is log base 7 of x squared is equal to log base 7 of 27 times 3 is 81. Now I can set them equal to each other. So I have x squared is equal to 81. To solve, I would take the square root on both sides. And we all know the square root of 81 is 9. So x is equal to 9. Oh, before I forget, when we take the square root, we get 2 answers, plus or minus 9. So we need to really think, well, will my answers work? If I look here, okay, I have just an x, okay, but it's really, so if I have just an x, could I plug in the negative? I could not plug in the negative, so we would just have x is equal to 9. No plus or minus in this case, but just one thing to remember, when you do take that square root, you get those 2 answers. Okay, but in this case, we can only have positive because you can't take the log of a negative. All right, that will do it for section 9.3 notes. If you have any questions, please write them down. Ask me in class. Otherwise, have a great day, and I will see you later.